Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Counting Sum Dots by Andrew Sarkis. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have sum dots, where digits on cells touching a sum dot sum to the value of that sum dot, which in this puzzle must be deduced by the solver. In this puzzle, if any sum dot has a value of n, then exactly n sum dots have a value of n. And digits on a sum dot may repeat if allowed by other rules. So you could have something like, say, 3, 3, 2, and 1. And this sum dot would then add up to 9 because these 4 cells touch this sum dot here. This sum dot would add up to 5, so there would have to be 9 sum dots which contain the value of 9, and then 5 sum dots which contain the value of 5 in this case. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, let's count the number. So for one thing, there are in box 7, we have 2 sum dots which contain 4 unique digits in it. That means one of the sum dots, at least, is 10. And it could be these add up to the same sums. That is potentially possible. But we have at least one digit which must be greater than, well, we have 2 sets, 3 sets, which are the sum of 4 unique digits. So 3 sets of 2, which are the unique sum of unique 2 digits. Sorry, uniquely 4 digits, which means at least one of them, it can't be 10 and 10. It can't be 11 and 11. What are the combinations that could have repeats? Well, that means the other digits would have to add up to an odd sum. So 45, you have at most 2 digits missing. So 45 minus 8 and 9, 17, would be 28. So you could have 2 sums adding up to 14. Oh, that's not true. You have a repeat here. You have a repeat digit. So it would have to be greater than, well, Okay, 7 digits can add up to 21. No, it's 28. 7 digits add up to 28, and you have a repeat digit once. So that means if you have these sums are repeated, it has to be at least 15, right? Because 28 plus 1 is 29. The 2 sums have to add up to the same sum. If I'm trying to basically match the sums in each box. So if that's the case, you have 15 at least. How many sum dots do we have? 1, 2, 3, 4, 5. Oh, this is gonna be hard. Let's just count per box. We have 4 here. So 4. This is another 4. That's 8. We have 1, 2, 3, 4, 5, 6 in box 3. So 4 plus 4 is 8 plus 6 is 14 so far. None in box 4. We'll do between boxes sometime soon. 1, 2, 3, 4, 5, and 6, which gives us 20 total. For box 5, none in box 6. 1, 2, 3, 4, 5, and 6 in box 7. So that's 26. Box 8 has 3, it's 29. Box 9 has 4, which makes that 33. So 33. There are 33 dots so far in boxes specifically. Across boxes, we have 1, 2, 3, 4. So that's 37. We have 37 sum dots here. That's quite a bit. So you could have 2 sets of... but the thing is, okay, how many are across 4 digits? We have 1, 2, 3, 4, 5, 6, 7, 8 across 4 digits. That means the sums can never be greater than 17 because we can't have more than... We have only 8 which are the sum of 4 digits. And they're all along the positive diagonal, right? This is 4, set of 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 4. That means they all share 1 digit with another, at least 1 digit, or exactly 1 digit with another set. Well, not exactly 1. It could be 1 or more. Interesting. We have 37 of them. Let's just make sure we have it. So 3 here, 4, 5 here, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. Yep, 37. Okay. 37 sum dots. That means you could have something like 10, 12, and 15. You have to have... Well, not necessarily. Do we have any combinations that are interesting? This is an interesting combination. We have basically all but 1 digit is included in a sum dot of two cells each. That's interesting. Same with this. We have 1, 2, 3, and 4. So they must sum to different sums for that. Hmm. 10, 12, and... Okay, so for three sums, say we have three sum dots total, summing the three sums. You could have the smallest for 3. Can you have 2? You could technically have 2. No, you can't. 18 and 19. So you have to have 3 sums at least. You probably have more. But for 3 sums, the smallest number would be 11, 12, and 14. So 14 would be the smallest, largest sum. Um, hmm. Each sum so you can't have 1 and 2 because they're all at least 2 digits in the same row or column. Um, you have to have one 2-digit number. So what can you not have? You can't have 3, 3, 4, 5, 6. Um, 7, 8, and 9. Obviously, it's 42. You could have 3, 4, 6, 7, 8. No, hold up. 42 minus 1 and 2 is 45 minus 3, which is 42. Yeah, you could have 3, 4, 6, 7, 8, and 9, but the problem is you need a 10 guaranteed at least. But these could be the same sum, technically. Either that or you have at least 2, which are the same sum. 2 sums that are the same, essentially, that are in the teens. And that could be possible. Hold up. You have 4. If these, so the interesting part here is if these 4 sums are different, that would mean they have to add up to at least, well, first of all, they cannot add up to more than 37, right? In fact, they would have to add up to 37 exactly because there's no sum that's going to ever add up to 1. So that you can't have 36, this be a 9, and then this another sum's going to add up to 1 because none of these sums are going to ever add up to 1. So it would have to be, so if these sums are all different, that would mean this has to be 8. But that means all of these sums would have to be one of them. These would have to have a duplicate. Interesting. In box 5, right? Because this is a sum of digits. This is a sum, this is a sum, and that's a sum. We also have similar ones here. This is a sum, this is a sum, this is a sum, and that's a sum. So in boxes 2, 5, and 7, actually maybe 3 also. Yes, 3 also. We have 4 sets of digits. So box 2, box 3, box 5, and box 7 have 4 sets of 2 digits each, adding up to a sum. So you're going to have a duplicate in a couple of them. Well, technically, you could have these all be different in box 3, 5, and 7. That is potentially possible. And then the box 2 would have to have something that's the same. That is possible. Right, because you can't have. So the problem is box 2. If you have box 2 and box 5 all different, that's fine, because then you would have 8 and 8 here, right? Oh, but that can't work. Because if you have 8 and 8 here, this is at least 18. But we know none of these sums you can only have 8 sums which have 4 unique digits in it. All the rest are 2 digits, 2 unique digits. So this does not work. That means we have to have duplicates at least in 2 of these 3. Interesting. For at least some of them. Huh. So we have 8 sets, which must be the sum of 4 digits. We have... That means the remaining 37 minus 8, which is 29 sums, must be 2 digits each. Okay. Hmm. Hmm. So at least 2 of these boxes out of 2, 3, and 5 has to have a duplicate sum in for at least 2 of their sum dots. Okay. Hmm. For a 4-set sum dot, for a 4-cell sum dot, you can't. I guess you could have 17. No, you can't. Or maybe you can. It's because, okay, so in box 4 and box 6, there are no digits in those which are part of the sum dot, which means 8 and 9 twice cannot be adding together to add up to 17. That means we are left with 2. Sorry, we have left with 9 minus 2, which is 7 possible combinations of 17, which means we would need 10 combinations for the 4-digit sums. So 17 is ruled out. 16 is also ruled out for the same reasoning. We are missing 7 and 9 twice at least. Oh, but that's not true. It could be like something like 8, 9 here, 8, 9 here. But then it would have to be 8, 9 with another digit. So across board, if you cross boundaries, this then still gives you only 2 across these boxes. This is also only this doesn't even have anything. So we still have the same thing, right? If I was thinking you could also cross boxes and then you could have multiple sets of 8 and 9 or 7 and 9 combining together. But that's not true because of the way that the dots are set up. Right? This would be 8, 9, 8, and then where's the other 9 that's part of? It's not there. So you cannot have 17 because 2 sets of 8 and 9 are not involved in a pair. And then that leaves, so that's 7 sets around a two set dot. And then that means we have only 7 plus 8 at most because there's 4 unique digits, or 4 digits surrounding a dot 8 times. And that's 15 total, which means 17 can't work. You have the same problem with 16. We have 8 dots, which have 4 unique digits around it. So that's 8 at most there. And then again, you have 7 and 9 only accounting for 7 pairs of dots, which means that's that is 7 plus 8, which is 15. So you cannot have 16 or 17 as the sum. So that means the sums are from 3 to 15. Okay, we have to have one sum that's at least 10. Okay, so if we have... 15 and 15. Technically, so 7. Oh, that's interesting. How does that work then? So you can't have, again, you can't have 16 and 17 for the sums of 4-digit numbers. Sorry, the 4 unique, or 4 digits touching a sum dot. That means it's guaranteed to be 15 and 15 at most. Oh, that's fascinating. And every time... So because of that, what are these 7 digits adding up to? It can only be 14 and 15 or 15 and 15. So you're guaranteed to have 15 at least. And this must be... So the digit in the middle... Oh, that's fascinating. Okay, 15 and 14 would be 29. That means you have only 8 more sums left. So right, 17 and 16 are not possible to be sum dots. That means 15 is the most. And for these 7 digits in boxes, what is it? Boxes 3, 5, and 7, you have to add up to at least 29 for the sums. which means those sums have to be 15 and 15 or 14 and 15. If it's 14 and 15, you have 8 more sums left. 15 and 15 is okay. Does that even work? I don't think so. So if we have 14 and 15 as the sums, first of all, 1 would have to be in the middle for all of them, right? Because these are adding up to 28 for these 7 digits, and then you add the 1 a second time because it's counted twice. So that would mean this is 8, 9 here, 8, 9 here, 8, 9 here, 8, 9 here. So 14 and 15 would force that situation to be the case. 8, 9, 8, 9. But that's problematic. So if you have 14 and 15 adding up to these sums, the problem is, how are you going to get that many 14 and 15s in the rest of the boxes, right? So you have 4 each here. That means you have to have 10 15s and 9 more 14s, or some combination, right? The problem yeah, I just don't think that's gonna work, right? So again, this is specifically to have 14 and 15. To have 14 and 15, that means they add up to 29 here, which is the minimum you can have for these 7 digits, plus this central digit adding up multiple times. And we have these 8 and 9s, which are not part of the set, adding up to with 4 digits, is only part of 1 pair each. So this is part of 1 pair. That's part of 1 pair. Part of 1 pair, part of 1 pair, part of 1 pair, part of 1 pair, which can add up to 14 and 15, right? To add up to 14 and 15, 15 requires 6, 9, or 7, 8, which requires an 8 or 9. And 14 requires 5, 9, and 6, 8, which also requires an 8, 9. And since these are part of only 1 pair each here, this is only going to be part of 1 pair in this set. This could be part of 2. So how many 14 and 15s are left? We have 8 14 and 15s around the cells that are touching 4 cells, or the dots touching 4 cells. So that's 8. We need 20. We need 14 plus 15 total, which is 29. 29 minus 8 means we have to have 21 pairs adding up to 14 and 15. But if we have 21 pairs adding up to 14 and 15, this is 1. You have 1, 2, 3, 4, 5, 6. You have at most 7, 8, and 9 here. You have 3 possible in box 1. You have 2 possible in box 2. Because this can't be... These are all part of 1 pair. We have 8, 9, and 8, 9 here, which requires the 14 and 15. So that's 3 in box 1, 2 in box 2, that's 5, 2 in box 3, that's 7, 2 in box 5, none in box 4, none in box 6. So 3 plus 2 plus 2 plus 2 is 3 plus 2 plus 2 plus 2 is 9. We have 2 more in box 7. That's 13. This could be 3 more here. This doesn't matter. It's the same. So this is possibly 1 here or 2 here. So that's 3 at most there. So that's 11 plus 3 is 14. And then we could have 4 pairs here, which is 14 plus 4 is 18. So we can only have 26, 8, 17. We can only have 26 that sum to 18 and 19. Sorry, that sum to 14 and 15. And then we have to have 29, which is not possible. So this cannot be adding up to 14 and 15. It must be adding up to 15 and 15. Which means, so therefore, that means we have more unrestricted things. Remember, these add up to at least 29, but you cannot have 16 as a sum. You can't have 17 as a sum because we just don't have enough dots to cover that many in the space, in the boxes that are available. So therefore, 15 is the most. It must be 15 and 15. So this has to be 15. This has to be 15. Same with these. That means in the corners, we are guaranteed 8 or 9 or 7 and 9. Right? To add up to 30, this is doubled. So we have 28 guaranteed here. That means 1 and 2 is in the middle. 1 and 2 is in the middle. 1 and 2 is in the middle. If you have 15, you're always guaranteed then to have 15 and 15 because you cannot have 14 and 15. And you can't have 14 and 14, obviously, because that's too small. That only adds up to 28 with one of the digits being doubled, but 1 through 7 adds up to 28 without the digit being doubled. So 1 through 7 is 28, plus 1 is 29. Obviously, you could have a 2 there, and that would be fine. That means on the corners, you're guaranteed a 9. Because if you try to have a 9 within the set of 7 digits, 1, 2, 3, 4, 5, 6 plus 9 is 30. And then you double another digit to be counted twice. That would mean it would be 31, which would have to include a 16 or above, which we know we can't have. So these sets always, so we could have 7 and 9 on the outside, and 1 in the middle, which would add up to 15 and 15 there. Or we could have 8 and 9 on the cells that aren't part of the 4 cells in a certain box. But we are guaranteed this must be 9 here. This must be 9 here. That's 9 and 9. This is 7, 8, 9, 7, 8, 9, with a 9 being here and a 9 being here. So because we are guaranteed, you can't have 14 and 15. So 14 is ruled out as a sum. You could have 15s, though. And we have 6 of those at least. And yeah, we could have 9 very easily as just 2-digit numbers. So we are not guaranteed those here around these ones that are in multiple boxes. So we have 15 as a sum. That means we have how many remaining? 22 dots remaining. Um, hmm. 22. So we could have something like 10 and 12. We can't have 14, as we've noted. 13 seems doable, though. You could have something like 9 and 13. Um, hmm. You have to have. You could have a sum of 10. No, one has to be part. Okay, so in boxes 3, 5, and 7, we are guaranteed one has to be in a set with another. Well, that's not true. Technically, you could have 1 and 1 here. I was thinking that we are guaranteed one that has to be below 10, but that's not necessarily true. Huh. Because 1 can never be in boxes 3, 5, and 7 with 9 as a pair. But it could be here and here and here, technically. So what happens if that's the case? So say we have 1 here, 1 here. This is 2 and 2. If that's the case, this has to be 1 through 7 here, which does guarantee that. Right. Okay. So either 1 is going to be a part of a pair with a non-9 in these boxes, or 2 is going to be part of a pair, and if 2 is in the middle, it cannot. That means the 2 is doubled, which means it must be 1 through 7 adding up to 28 plus the 2 adding up to 30, which gives us 15 and 15, which means 8 and 9 have to be on the outside, which means 2 has to be summed with a digit that's less than 8. So we're guaranteed there has to be a sum that's less than 10. So it cannot be 10, 12, and 15. It could very well be, though, 9, 13, and 15. Or we could have multiple sums, right? We don't even have to have 9, 13, and 15. Um, hmm. um, huh. Again, we have to have duplicates, but we are not required that they have to be 6, 7, 15, and 15, right? In fact, you could have all the four cell dots add up to 15, and then we have one set of 15 in each box that has a pair. And that would work. Um, hmm. Okay. Um, Multiple dots adding up to 22. 6, 7, and 9. That works. Uh, 5, 8, and 9. We are guaranteed, though, I think in box 2... That's not necessarily true. So we know these sums add up to 15 and 15 here. So we have 6 15s here. The rest add up to 22. The thing is, you could have 15 with 3 other ones, right? What happens if these are all unique digits or unique sums? Well, is that possible is the question, right? Again, it has to add up to 37. One of them must be 15. So that would force one of these to be 8. So that means it would be 8 here. We'd have 6 and 9 adding up to 15. Oh, that can't work here. So these have to have a duplicate in box 5. If we try to have 8 here, and we can't have 6 here because 6, 8, and 1 add up to 15 already. 6 would have to be one of these to add up to 15 here. And that doesn't work. Interesting. So it cannot be 4 unique sums here because 15 is guaranteed to be one of the sums. That means there's a duplicate sum here somewhere. Excuse me. That means, oh, that's interesting. I think these are all set up that way. Right. Yes, they are all set up this way. Boxes 3, 5, and 7. If we try to have this be 15, and it has to be for these, only one of them can be 15, right? You cannot have both of them be 15 because if this is 15 and this is 15, you're guaranteed this is 6, 7, and 8 here. 6, 7, 8 in any of these boxes, right? Or 6, 7, 8 here. The problem with that is you have 1, 2, 6, and 7 at minimum for these 4 cells, which is 1, 2 is 3 plus 6, 7 is 13, which adds up to 16, which you cannot do. So only in each of box 3, 5, and 7, we have only 115 possible. That's still very likely, right, to be fine. Because we could have two of them in box 2, we could have 2 of them in box 1, we could have 2 of them in box 8, and 2 of them in box 9. Those are all possible to have 15. So we're guaranteed 6 15s in around the 4 cell sum dots, which are only in one box. We are guaranteed at most 3 for these those same boxes. That gives us 9. With 2 more, that's 11. So we have to have 4 more, which is certainly possible in the rest of the boxes, right? Because we could have 2 available in each of the rest of the boxes. Okay. Um, okay. 1 and 2 are going to have to be together, though. Somewhere as a set of 4 digits. That adds up to 3. 15 minus 3 is 12. You cannot have a 9, so that eliminates 3, 9. You could have... It's either 4, 8 or 5, 7. As the remaining 2 digits, whichever one has 1 and 2. Okay. That means... Right. The remaining digits have to be 3 with 1 or 2. Which could work. Hmm. Hmm. In each of box 3, 5, and 7, we are guaranteed 9 as with a pair of 2 digits. So it's either 10 through 15 there. Hmm. Um. Hmm. What does that tell us, though? I don't know. I still don't know what the sums are, though. You could... obviously, we have 15. You have to have one digit that's less than 10, because the 1 or the 2 has to... 1 has to be with 8 or less, or 2 has to be with 7 or less in some sort of combination. Four times, we have the sum of digits adding up to 36 or higher. Actually, well, in 3 of the times, it's 37 or higher. Right? Um, 3 of the times it's 37 or higher. This could technically have a 9 there, so that could be 36. And you have to have a duplicate. Hmm. Part of the question, though, is can you have a non-15 in as one of the digits, as one of the sums in a box? I think the answer might be yes, right? Um, hmm. If you have the rest are single digit numbers, though, it has to have, well, you could have 9999, right? That is potentially possible. Hmm. Can you have a non-15 in a box which doesn't have the 9 as not part of a pair? Oh, well, these are all part of a pair. So you're guaranteed that has a 9 somewhere. Um, oh, okay. What other combinations can we have? So we have to have a digit less than 10. Or sorry, some less than 10. So it cannot be 10, 12, 17. 10, 12, 15, we know that for certain. But you could have multiple sums, right? So you could have something like 5, 8, 9, and 15. 6, 7, 9, and 15. Um, are you guaranteed to have another sum that's greater than 10 is kind of the question, right? Because then that limits things a decent amount. I mean, you could still have like 3, 9, and 10, right? For 3 digits, for 3 sums. Hmm. Oh, that's interesting. Boxes 2 and 3 have all the digits are part of a pair. That must add up to 90. Right? So these two are a pair, these two are a pair, these two are a pair, these two are a pair. So are these two, these two, these two, these two, these two. So in addition to this having 4 sets adding up to, huh. Does that help us though? That's 9 pairs, which means they must average to 10. Um, but is that helpful? I don't know. Obviously, there's duplicates in there. I mean, technically, you could have all of them be 10, right? But that's going to be. Yeah, you could have 3, 9, and 10 then, if that's the case. Um, huh. Um, wait a second. We know, okay, this adds up to 15. That means these are the sum add up to 15. Oh, that's oops. This adds up to 15. This sorry, this as a whole adds up to 15. So these two must add up to 15. Interesting. So that means this cannot be 15 and 15 there, right? So that is certain there. So so we know there's two sums that add up to 15. So that's 30. Um, we know there's two sums that add up to 15. You cannot have another two sums that add up to a different 15. So you can't have 6 and 9 as a sum, and you can't have 5 and 10 as a sum, because that's way too many sums. 5, 6, 9, and 10 already add up to 30, plus 15 adds up to 45. So that's too many sum dots then. So the sums that add up to 15 are guaranteed. So then we have two sums adding up to 15. We have 15 as a sum, and then we can only have one more sum. Or technically, that's not true. We could have 3 and 4. So we have the two sums adding up to 15. We have either a 7 there, we have 15, obviously. So that's 30. So it's either 15. We have 15 as a sum. We have two sums that add up to 15. Either 3, 12, 4, 11, 5, 10, 6, 9, or 7, 8. And then we also have either two sums adding up to 7, 3 and 4, or a 7 as a sum. Okay, that's good to know. That means this sum is the same as one of these two. So obviously both of these cannot be 15. So you could have, okay, so the combinations of sums are either 3, 7, 12, 15, 4, 7, 11, 15, 3, 4, 5, 10, 15, 5, 7, 10, 15, 3, 4, 6, 9, 15, 6, 7, 9, 15, or 3, 4, 7, 8, 15. And those are the possible combinations. Okay, that's a quite a few combinations though. So that's a lot of combinations. Right, and that's all because we know this must add up to 15. So these two sums add up to 15, so they must be less than 15. And we can't have an extra one unless it's 3 or 4. Okay. Hmm. Hmm. Okay, so what are the combinations then? We know we are guaranteed 3. So this has to be either 1, 2. These are guaranteed 3 sets here. But that doesn't help us much, right? We already know there's at least 3. It's 3, 12, 3, 7, 12, 15, 4, 7, 11, 15, 3, 4, 5, 10, 15, 5, 7, 10, 15, 3, 4, 6, 9, 15, or 6, 7, 9, 15, or 3, 4, 7, 8, 15. I don't. Oh. Hmm. Oh, interesting. So this cannot add up to 15. This is less than 15. In fact, this has to be less. This is at most 12 here. Because this could be 1, 2, 1, 2, but this has to, with this sum, add up to 15 at most. It could be less than that, too. Uh, um, so we know this is 15. This adds up to 30. Okay. One of them could be 15. Can you ever not have a 15 is kind of what I'm thinking of. If you have 5, 3, 4, 7, 8, the answer is no, you would have to have 15 there. But you cannot have two 15s. So the 15 here would have to be, well, we don't really know. No, they have to be 6 and 9. So 3, 4, 7, 8 seems it's way too restrictive. Okay, so let's write down the possible combinations again. We have 3, 12, and well, we know 15 is the last one. So it's either 3, 7, and 12, 4, 7, and 11, 5 and 10 with 3, 4, 5 and 10 with 7, 6, 3, 4, and 9, 6, 7, and 9, or it's 3, 4, 7, and 8 in 15. I think 3, 4, 7, 8 might be too restrictive. So if we have 9 here, yeah, it's too restrictive. If we have to have 9 adding up, well, maybe, hold up. No, this can't add up to 15, so that's the problem. So if we have 9 and 6 here, 9 cannot add up to 3, 4, 7, and 8. So it has to be adding up to 15. So that would be 9 and 6 here. 9 and 6 means we have to have an 8 somewhere, adding up to non-3, 4, 7, 8. But this can't add up to 15 because it's part of a larger quad, which must add up to 15. And none of the other ones can add up to 15 because they're part of a quad. And we can't have 15, 15 here because that adds up to 15, 15, 15, and that's 45 without this extra digit, which is too large. So 3, 4, 7, 8, and 15 does not work. 6, 7, and 9 could potentially work. Um, let's see. Can you ever actually have the 3, 4 as the non-pair adding up to 15? I don't think that works. Um, well, maybe. You could have technically 1 here, 2, and 3 there. That could be possible. Then you have 1, 2 as a possible. You would have to have it in 7 boxes. You could have, again, multiple ones there, multiple ones here, multiple ones here, and then a 1, 3 in one of these in this box. So that is possible. Hmm. Um, Interesting. So again, one of these quad dot sum dots, has to have 1, 2, and 1, 2. You can't have 3, 9 added to it. You could have 4, 8, or 5, 7. So if the 9 is adding up to 15 with 6, that means this would have to be 1, 2 around here. Which could certainly work. Can you not have the 15 is kind of also the question, right? Um, 6, 7, so 6, no 10 or above means 9 always has to add up to 15. So we would guarantee this has to be 6 in one of these boxes. You cannot have 7 or 8 with that. Um, hmm. Okay, so one thing is we know we can't have 3, 4, 7, 8, and 15. So these are the possible combinations. So let's try to not have um 3 and 4. Sorry, let's try to have 5, 10 with 3 or 4, or 6, 9 with 3 or 4 as a set. That's what I'm thinking of. So, again, these cannot be 3 and 4 because we have 6, 9 as the pair that's adding up to 15. So, where are 1, 2, and 3 have to be? One of these is going to have to be 1, 2, or 1, 3. I guess you could use that. You can't use this? You may be able to use that. That is kind of the problem, right? Well, okay, no, this is part of. So we only have a certain amount of ones, which adds up to 3 and 4. We don't have the 1 available in this box. Well, technically we could. We could have 1, 2 there. And then you could have 1, 3 there. Okay. You can't have 1, 2 here. You could have 1, 3 here though. But it doesn't add up to with another 1. And these are interesting. So okay, what about if we make this 1? If that's 1, this is 2. We have 2 and 3 possible here. We could have 1 being there. So this is 1, 2, 3, which means this can't be 1, 2, or 3. 1 eliminates 1 here, so that's 2. This can't be 1 here. This can't be 1 here, so 1 has to be one of these two. And 2 and 3 here. That's potentially possible. That means 1 has to be one of these two here. So you could have 1 and 3 there. But that's a little problematic. We don't have 1 and 2 of, so this is 1 and 3. We have 1 and 2 and 3 here. One here cannot be with 7, 8, or cannot be with 3 or 2. So that's the problem there. We could technically have 1 and... No, we can't. Right. In each of these boxes, 1 and 3 and 2, 1 and 2 can't be together. 1 and 3 cannot be together because they are not the sum. So I think that's a little problematic. So obviously, if we try to have that as 1, and this is 2 and 3, 1 can't be here. So basically, where are the ones available? Where we can add up with 2 and 3. Cannot be, I mean, technically, it could be here. So in box 7, you could have 1 and 3 be there. In box 8, where are the 1, 2s possible? I guess I wasn't thinking of that. Well, okay, box 7. This adds up to 15, and again, we are using this as 6, 9 with 3 or 4. So this cannot be 1, 2, 1, 2. That means none of these could be 1, 2, 1, 2, but this could be 1, 3. So that could be one that we take there. You can't have 4 digits surrounding a box adding up to 4 to add 3 or 4, because that would have to be 1, 1, 1, 1, which means you have a duplicate in a row somewhere. So this is possible. Obviously, you could have 3 here. You could have 3 here, or 2 available there, each. Not here. You could have 1 potentially here. You could have 1 in one of these. And you could have 2 here or 2 here. Okay. What happens if this is 1, 3? If this is 1, 3, this is 2. This cannot be 1, 2. This can't contain 1, 2, or 3. So that means we have 1, 1, 3 available in these boxes here. No 1, 2, or 3 here. This is 5 through 9. So this can't be 1, 2, or 1, 3. This could. So this is 4 through 9 here, which means this cannot be 1, 2, 1, 3. This is 4 through 9 here, so it cannot be 1, 2, 1, 3. So if this is 1, 3, that really limits things a lot. That means we can have at most 1, 2 here. And we have to have 5 more 1, 2s and 1, 3s. Technically, you could have 1, 3 here, and then 1, 2 as one of these. 1, 2, and 3 there. But this 1 would force a 2 there. And then we don't have that working. So we have a 1, 2 here, a 1, 3 here, a 1, 3 here, a 1, 3 here. Say we have 1 and 2 or 3 here. So that's 1, 1, 2. We need 2 more. Only one of them can be here. One of them has to be here. But then that doesn't work because you have 1 and 2 here. So that's problematic if this is 1 and 3. So we have to just ignore that one. So we ignore that one. What about if we try to make this one? So 1 and 2 or 3. This we're trying to make 1 with 2 or 3 here. And 2 or 3 there. That forces this to be 2. We could have 3 with a 1 in here. So that could work. 3 and 1. And then this is 2. That's 3. That's 2. This can't be 1 here. So you could have 1 and 2 and 3 there. So we have 1, 2 once. 1, 2 twice. 1. This is... Oh, this can't be 1 and 2. Oh. That's problematic. Huh. So we have 5 potential 1s available here, right? We have to have 7 1, 2s and 1, 3s. So either we use a 1 here, and then we have 2, 1, 2, and 1, 3 pairs. So either this could be 1, 2, and 1, 3, this could be 1, 2, 1, 3, or 1, 2, 1, 3 here. But, so if that's the case, if we have 1, 2 here, and this is 2 or 3, this is obviously 2. 1 can't be here. 1 can't be here. So if we try to have this as 1, this can't be 2. So we'd only have 1 available here because 1 would force this not to be 1, so that would be 2. And I think this is problematic. So this cannot, this has 1, 1, 3. This, I guess it could be 1, 3 here. So you could have 3 and then 1 there, which means this can't be 3, that's 2. You could have 1, 3, and 2 there. 3 and 1, not that way. 3 and 1. So this is 1, 1, 2. Another 1, but that's only 2. And then we have 1, 3, 1, 3, 1, 3, 1, 3. Because this cannot be doubled. This can't be doubled. What happens? So what happens if this can't be doubled because that would eliminate all possibilities for that cell there. So this is only 1 at most. This is only 1 at most because it can't be doubled. 1 has to be To have a double here, it would be 1 here, and then, but the problem is this can't be 2 because of 2 in the bottom column. And this can't be 1, 2 because that has to be 1 or 2. So this is a singleton, this is a singleton, this is a singleton. That's only 3 1 2s or 1 3s. We can have a 4th here, and then this is 5 and 6, but we don't have enough. We need 7. So that cannot have that 1 there. We tried this 1 being here as 3, and that doesn't work either. So this doesn't work. We need 3 sets of 1 and 2 and 3. So this has to be 1 with 2 or 3. This is 1 with 2 or 3. This is 1 with 2 or 3. That makes this 2, though. This can't be 1 anymore. So 1 makes that 2. This has to be the 1 to have a 2 or 3 here. So this is 3, which makes that 2, and then that's a contradiction. So no, you cannot have 3 4 as with a 6 9 or 5 10 pair. So 7 is guaranteed as a set. Interesting. Oops. So this is not allowed, and this is not allowed. So we're guaranteed a 7. So it's either 3 12, 4 11, 5 10, or 6 9 as the possible sets, with 15, obviously. 7 and 10, and 6, 7, and 9. So we're guaranteed 7 and 15 as the sets. And then we have 12, 11, 10, and 9. So 3, 12, 4, 11, 5, 10, or 6, 9. Okay. Six, 7, and 9. That means this would have to be 15. And we have 6, 7, or 9 here. That does not work. So we know this adds up to 15. If you have 6 and 9, the other digit is 7 or 8, and it can only add up to 9, which means that's 1 or 2. But 1, 2, and 6 adds up to 9, so we need a 6 here to add up to 15, which doesn't work. So 6, 7, and 9 is not possible as a combination. 10 potentially could work. So we have 3, 12, 4, 11, and 5, 10 all potentially working. Okay, one thing you can... Okay, if you have 10, you're guaranteed one of these is 15. But that doesn't tell us very much, right? Because you can't have 10, 10 here, because this is 15 plus 10 would mean one single digit has to add up to 10. And that can't work, obviously. Um, you could have potentially 11 and 11. Yeah, that could potentially work. Does that work? Hold up. 11 and 11. So you would have to have 2, 3, 1, but that would force that to be 9. 2, 4, 1, and 8 does work, though. So 1, 2, 4, 2, 4. This becomes 7, 9. And that's 8. So 11. So you have 4 and 11, which makes that 3. And 11, so this is 5 and 6. So that could work. 10 and 10 obviously don't. 12. 12 and 12 could work. That would mean this is 12 and 12. You have 6 here. Okay, so what are the possible combinations? Obviously, these can't be 3. These can't be 3 or 4 or 5. So it has to be, it's either, we have, so possible combinations here. So again, you can't have 6 there. Because 6 and 9 doesn't work. Because it would have to be 6 here with a 9, and then 1 or 2 with 7 or 8. But 1, 2, 6 adds up to 9, plus 6 must add up to 15. Okay. So either you can't have 10 and 10. That makes a 10 there. You could have 11, 11, and then this is 8. You could have 12 and 12, and then this is 6. You could have 15 and 10, and then this is 5. You could have 15 and 11, and then this is 4, or 15 and 12, and this is 3. So these are the possible combinations. You have 3, 4, 5, 6, 8. Interesting. And that's for all of these. These 2 digits added together cannot add up to, it has to be at least, at most 12. Okay. This specific, okay, so this can't be 4 here. That's interesting. This specifically cannot have 1, 2, 4, and 8 there. Because, so they can't have 11 and 11. Because that would be 2, 4 as a pair. This would be 1 and 3, and you'd have to have 5, 6 there, which is impossible. So you cannot have 8 there. You could have 12 and 12 adding up to 6 there. Hmm. If you have 3 and 12, this has to be 1, 2, This would have to be, cannot be 3, 9 because of 9 in the corners. Cannot be 5, 7, so this would be 4, 8. Which means this can't be 8, this can't be 8. That is possible. So then this would have to be 1, 2, 1, 2. We'd have 1, 2, 1, 2. This would be 3, 5, and 6. 3, 5, and 6 would force 2 to be here, I believe, right? 2 and 1. No, that doesn't work. It has to be 1 there. Right, because it's, yeah. That certainly seems feasible. Six cannot add up with 7 or no, it could be 6 and 9. Ugh. Right. Hmm. That means this is 11 at most. Cannot be 9. So far, that seems fine. Hold up. What does that tell us? So, this can't be 4, which would be 15 plus 11 here. So that means 4 and 11 can't work that way. You can't have 11 and 11 here, which would make that 8, because then this would be 2, 4, 2, 4, 1. You'd have 1 and 3 here, and this would have to be 5, 6. So you cannot have 4 and 11. It's either 3, 12 or it's 5, 10. Interesting. So the combinations then are 3, 12 or 5, 10. And then you have 7, right? Interesting. Okay. This would then have to be 7, right? So we have 37 sums. Actually, I guess we don't need that because we know it's 3, 12, and 3, 7, 12, and 15. Or 5, 7, 10, and 15. Because we ruled out 4 and 11 here. Because of the 5 here and the 4 here. This cannot be 12. But it could be 10. And it could be 5 even. If you have 3, 7, 12, we don't know what that is. Well, we know if it's 3 and 12. So we have 3, 12. That means there's no more 3s as sums. 12 and 15 cannot have 1 and 2. So that means in this box, 1 and 2 have to be part of a 7. 7, 7. You could have two 15s though. No, you can't have two 15s. This is pretty tough. Interesting. Um, I was hoping that the 312 would be restrictive enough that we could find a contradiction, but so far, no. So every digit in box 2 and 3 is part of a pair. Interesting. 5 and 10 does not work then, because every digit is part of a pair in box 2 and 3. 5 cannot add up to 5 with another digit. 5 cannot add up to 10 with another digit. 5 cannot add up to 15 with another digit. Which means 5 must add up with 2 if you have 5 and 10 to add up to 7. Obviously, it cannot be here. So this cannot be 2 and 5 here. So where is 5 adding up to 7 here? Can't be here, can't be here, because it's 5 and 10 as the sum adding up. Can't be any of these, because, again, 5 cannot add. So 5 has to add up with 2 here. So you have 5 and 2 there. But the 5 can no longer add up with another digit here to add up to 7. And again, it doesn't add up to 5 with another digit, can't add up to 10 with another digit, can't add up to 15 with another digit. So therefore, it cannot be 5 and 10. It has to be 3, 7, 12, and 15. That is crazy. Wow. Wow, wow, wow. How do you come up with that? That's crazy. So this must be 3 and 6 here. This has to be 3 and 6 here. This has to be 3 and 6. You have 1 and 2 adding up to 3. So this is 1, 2, 1, 2, 1, 2. And these are the only 1, 2s. This cannot be 3, 9. It cannot be 5, 7. It's 4, 8, which forces this not to be 8 here. So then we have 3, 5, or 6 here. So we don't have 3 anymore available. So 1, 2 in a box So this adds up to 3, 7, 12, or 15. Okay. 3 cannot, no, there's no more 3s. There's no more 3s available. So we don't have to worry about that because we have a set of 3, a set of 3, a set of 3. This has to be 3, 9, 4, 8, or 5, 7. No 3, 9. So these are 4, 8, and 5, 7s here. 4, 8, and 5, 7. 4, 8, 5, 7. No 5 here, so no 7 there. This is 4, 8 as a pair. So to add, this cannot be 15 because this adds up to 15. You could have 5, so you could have 3 and 2. Sorry, not 5, it's 3. So you have 7, 12, and 15 available. 7 could be 3 and 4. 7 could be 6 and 1. "12" cannot be here. If this is 12, this would have to add up to 3, which is not possible with 3 or 6. So this is adding up to 7, which means this adds up to 8. Well, you could have 12 here. We know this adds up to 7. This could technically add up to 12. So it's either 12 or 15. If this is 12, this is 7, guaranteed. Okay, so let's match 3, 4, and so 3 is going to be, we'll make those blue. 15 is the largest one, so that's a 15. That's a 15. That's a 15. 12 we'll mark as pink. So this is 12, 12, and 12. This is 15 also. So we have 15 here. Let's mark the 15's 4 sets as red. Okay. If this is guaranteed to be 7, so we'll mark that as green. 7 plus, this is either 5 is 12 or 8 is 15. Well, to get 8 here, it's 3, 5, which can't be 5 because of 5 in the box, or 6, 2. To get 5 here, it's 3 and 2. So this is guaranteed to be a 2 then. Interesting. We don't know which width. We don't know about these. This has to be, since this is 3, 5, and 6, that adds up to 14. So plus 1 is 15. And this is 1 and 2 there. Therefore, we have a 2 in one of these cells there. 5 is guaranteed to be one of these digits. Huh. Or this. So one of these 5 digits. So it's guaranteed to be part of a pair. It cannot be with 4 adding up to 15. It can be 5 and 2 adding up to 7. Or 5 and 7 adding up to 12. Huh. Okay. Let's just do remaining digits in... 2 can't be here. We also have to have a 5 here. So 5 has to be with 7 in one of these. And we need another 5 with 2 or with 7. Because it can't be adding up to 15. We can't no longer add up to 3. This can't be 4, so this can't be 8 here. Oh, we have a 7-8 pair here, so this cannot never be 7 or 8 here. So we have no 1, 2, no 9, no 7, 8, so it's 3, 4, 5, 6 there. Okay. We don't know what this adds up to, at least 9. So therefore it's 12 or 15 here. So again, we're going to make orange the 2 pair 15. Let's just say, figure out what the digits are. We have in column 7, 1, 3, 5, 6, 7, 8, 9. Obviously no 5 there. Column 8, 3 through 9. No 5 here. No 4 here. Remaining of column 9, we have 1, 2, 3, 6, 7, 9. Obviously no 2 here. Okay. Does that help us any? I don't really know. So we have 7, 10, 7, 12, and 15 available. Okay, this again cannot be 7 or 8, so this is 3, 4, 5, 6 as a possibility. So we know we have a 2 here. 2 cannot add up to 12, cannot add up to 15, so it has to add up to 7. 2 cannot be here either, so it must add up to 7 there. Okay. So that's 3 7s already accounted for. Remaining digits of column 5 are 3 through 9. Okay. This can't be 4 because of 4 in the row. So can you add up to 41 with the remaining sums, or 44? I'm pretty sure we did it with 44, okay. Huh. Yeah, 40. So no 3s are available. How many 7s can we have, possibly? Can we have 3 7s? 3 7s add up to 21. I think the answer to that is no. Yeah, 21 plus 15 at most is 36, which would force that to be a 9, which is not possible there. So, not 3 sevens. 2 sevens. Is 2 sevens possible? 7, 7 is 14. Plus 12 is 26. Plus 15 is 41. So that does work. 7, 7, 14, 15, 15 does work also. So 2 sevens does work. Can you have double 12? So 12, 12. Can you have triple 12? You can't have double 12 because 12, 12, 7, 7 doesn't add, it's too small. 24 plus 14 is 36, which we can't have a 9 here. 3 12s, 12, 12, 12, 36 plus 7 doesn't work. 12, 12, 15 is 39 plus 7 is way too big, 46. So I think you have to have 2 sevens and 12 and 15 or 15 and 15. Interesting. So there have to be 2 sevens here. Which gives us 3 sevens here. We have a 4 7 here because of the 2 being there. This could actually be 7 here. 3 and 4, right? We're actually missing quite a few 7. Well, are we? We don't have to be. Maybe I should look for the 15s. Hmm. We have 9 more 15s we need to find. We have 9 more 12s we need to find. And we have 6 more 7s. But we know there's a 2-5 combination here. So 5 cannot be here. The 2 cannot add up to 12, cannot add up to 15, and 3 is already taken 3 times. So 2 has to add up to 7 with 5, wherever it is. So this cannot be 5 here. So 2 can be one of these 3, which means 5 has to be correspondingly one of these 3. 2 could be any of these 6, which means 5 has to correspondingly be one of these 7. 2 cannot be here. 2 cannot be in a 1 to 2 ratio. Oh, these can't be 2. Okay, so then where is 5? 5 can't be here because it can only be add up to 2 with 2 to add up to 7. 5 cannot be here. 5 can't be either of these. So 5 is either here or here. Where is 5 in row 1 then? It has to be one of these 2, which means 2 has to be one of these 2. This cannot be 2 here. This cannot be 5 here. Not 2, 5. So 2 has to be one of these 2, which means this can't be 2. So 2 is one of these two, which means 5 is one of those two, which means this can't be 5. 5 eliminates 5 from being here. So this is 3, 6 as a pair. This has to be 5. 5 can only add up to 12, not 15. So this is 5 and 7, which makes that a 9. So this is pink. 9 and 3 or 9 and 6 here. That eliminates 3, 6, and 9 in the rest of column 7. So we're guaranteed 5 has to be one of these two digits, which means 5 cannot be any of these digits. 5 has to be with 7 to add up to 15, and only 7 because it can only add up to 7 or 12. It can never add up to 15. And 2 is not any of these, so this must be 5, which makes that 7. This can't be 7 here. This is 1, 8 as a pair. This eliminates 7 in the rest of the box. This 1, 8 pair eliminates 8 and 1 in the rest of the box. So 1 and 2 have to be here. This digit adds up 7. Can't add up to 7, obviously, so it adds up to 12 or 15. Therefore, this must be an 8. So that eliminates 8 in the rest of the box. 7 cannot be here. These must add up to 12 or 15 or 7. No 7's possible here. So it's either 12 or 15, which means we're guaranteed 9 is here, which means this cannot be 9. 9 must add up with this, so this must be 3 or 6, which means this can't be 3 or 6. This is 1 or 2. This is 1 or 2, because 1 or 2 cannot add up to 7. I guess this could be 6 and 1. Okay, so that's not right. So this could be 1. We could have still 1, 2, 3, 6 there. 9 is guaranteed to be one of these two, so 9 cannot be here. Where is 9 in row 5 then? 9 has to be one of these 3 digits. Interesting. 5 eliminates 5 here. 7 eliminates 7 and 8 here. 7 and 8 eliminates 7 and 8 here, so this is 9, which means this cannot be 9. 7 and 8 cannot add up to 15 here. It must add up to 12, because it can't add up to 7 either. And this is then 4 and 5. 5 eliminates 5 here. This can't be 5, so this is 4 and 8, which makes this 7 and 5 there. So this can't be 4 or 5 here. It's 3 or 6 as a pair, which eliminates 3, 6 in the rest of the row. So this can't be 3 or 6. No 4, 7 here. No 5, 8 there. Where is 5 in column? Well, we don't know. It could be any. This 9 eliminates 9 here. So we have 1, 2, 4, 5 remaining in row 7. Okay. Interesting. This can't be 9 anymore. This adds up to 12. So we have 9 and 8 on the outside. This is 3, 6, and 4. That adds up to 13. So this must be 2 here, which makes that 1. So this cannot be 1 here. Remaining... Okay, so this is 4. It can add up to 7, 7, 12, or 15. No 15, obviously. So 7 or 12, which makes this 3 or 8. 5 cannot be here, so this can't be 2 or 5, which makes this a 2 and a 5 there. So this is adding up to 7. That means 5 has to be one of these two. 2 has to be one of these two. 5 eliminates 5 here. So 7 can only be with 5 here, so this can't be 7. So you have 5 and 7 here or 5 and 7 here. Either way, 7 has to be one of those two. Right, this could be 1 and 6. That's the reason why I left the 1 back there. We don't have a 4 available, so that can't be 3 and 4. So either this is 9 with 6 or 3, or this is 6 and 1. We don't know. We know one of these two is a 9. But we already have that, though. 1 is guaranteed here, 1 is guaranteed here, which means 1 has to be one of these two. No 7 here. Remaining digits in row 3 are 1, 3, 4, 6, 8, and 9. No 9 here, no 1 here. Remaining digits in row 8. We have 1, 3, 6, 8, and 9. Remaining digits in row 9. We have 2, 3, 6, 7, 9. Okay. 9 eliminates 9 as a possibility there. Okay. This can never add up to 15. So it's either 7 or 12. Well, if it's 12 or 7, 9 can never be here. Because 9 would have to add up to 3 with 12. And 6 with 15. 5 can't be here. 5 can add up to 7 with 2, but there's no 2 here. 5 can add up to 12 with 7, but there's no 7 here. And 5 can't add up to 15, so this can't be 5. Where is 5 in column 6? Can't be any of these cells. Can't be here, so it must be here. So this is 5 and 2, which eliminates 5 and 2, which eliminates 5 and 2 here. That means this can't be 2, this can't be 2. So, this is 1 or 4. 1 only adds up with 6 to add up to 7. 4 can add up to with 3 or 8 to add up to 7 or 12. So we have a 1-4 pair, actually, in column 6, which eliminates 1-4 in the rest of the column. This can't be 4 then. We have a 3-6 pair in column 6, which eliminates 3-6 in the rest of the column. This can't be 3 or 6. It's 8, which makes this 9. That makes this 7. 7 and 8 add up to 15, which is, I think we're marking that as orange. So it's 8 and 1 does not add up, so it's 8 and 4, which makes this 5. This can't be 3, 6, or 5. It's 4 then. Makes that 5 and 7 here, which makes this 8. So that adds up to 12. This can't be 5 or 4. It's 1 or 2. No 8 here, no 8 here. This is 3, so this adds up to 7 here. So no 3 here. No 3 or 8 here. We have a 6-9 pair in row 8, which eliminates 6, 9, and the rest of the row. This can't be 6 or 9. It's 1, which makes this 2. 1 and 6 add up to 7. So that's satisfied there. 5 and 7 add up to 12. 7 and 8 add up to 15. 2 eliminates 2 here, so that's 1. This can't be 6. It's 9. 9 and 12. 3 add up to 12, but this can't be 3, so this is 6. That's 2. This cannot be 2 here. 6 eliminates 6 as a possibility here. So this is 3, 4, 7 as a triplet, which forces this to be 9 and this to be 3. That means this can't be 3 here. So this is the 15. Okay. 4 and 8 here. This cannot be 4. No 7 here. 4 eliminates 4 here, so it's 1, which makes that 1 and 6, so that's 3 there. This is adding up to 12. This adds up to 7. No 1, 6 here. No 6 here. No 3, 8 here. No 4, 9 here. The remaining digits in column 5 are 3, 7, 8. No 7 here. This is guaranteed to have a 7 here. It cannot be 3 and 7. That adds up to 10. It must be 7 and 8, which forces this to be 3. 7 and 8 is a 15. Remaining digits in column 4 are 4, 6, and 9. This can't be 9 here. We are guaranteed a 6 in one of these. 6 and 4 only add up to 10. So that's not valid, so it must be 6 and 9. So this is 9, that's 6, this is 4. Therefore, that adds up to 7. So we have 1, 2, 3, 4, 5, 6 digit sums that add up to 6, 7. The remaining digits here are 8 and 9 in row 3. 9 eliminates 9 here, so this is 8, which makes this 9. 9 is with 3 or 6 here. This can't be 3 because of 3 in the row, so this is 6, which makes this 3, which makes that 6. Therefore, this is a 15. This is a 12. 8, and we have, you cannot have 8 here. So it's 4, 7, and 8 as possibilities here. That cannot be 7 or 8, so this is 4, which adds up to 12. 4 and 3 add up to 7. So that's the last 7. So we don't have any more 7s. This is a 12. Which remaining digits here are 1 and 7. 1 can't be here because of 1 in the column. So that's 7. That's 1. Which makes that 8 and 7. 8 eliminates 8 here, so it's 4 and 8. This is 4, 3, and 6, which add up to 13. So this must be 2. This is 1. 1 eliminates 1 here, so it's 8 and 1. 2 eliminates 2 here, so therefore 2 must be there. We're missing a 1 and a 6 in column 1. So obviously this can't be 1. This is 1. This is 6, which eliminates 6 here, so it's 3 and 6. This adds up to 12. This adds up to 15. This adds up to 15. Okay. Let's just count this. So the 3s are 1, 2, 1, 2, and 1, 2. That's done. 7s, 3, 4, 1, 5, 2, 2, 3, 4, 3, 5, 2, 4, 1, 6, 5, 3, 4, 5, 6, sorry, and 1, 6, 7. So we have all the 7s. 3 eliminates 3 here, so that's 4. So no 4 here. 9 eliminates 9 here, so it's 6 and 9. Remaining digits in row 2 are 8 and 9. 8 can't be here because of 8 in the column, so this is 9, that's 8. Remaining digits, this can't remaining digits in column 2 are 4 and 5. This can't be 4 because of 4 in the row, so it's 5 and 4 there. So this is 1662, which adds up to 15. So that's satisfied there. And we have 3 and 7 here. Well, 1, 5, and 6 add up to 12, so that must be 3 there. So this is 3, that's 7, this is 3, and that's 7. Let's just count to make sure we have all the sums correct. All of the sums surrounding the quad sum dots are 15. Because this is 15 and this was 15. And these, again, had to be 15. 1, 2, 7, 5 adds up to 15. 2, 3, 4, 6 adds up to 15. 1, 3, 5, 6 adds up to 15. 1, 2, 5, 7 adds up to 15. 2, 3, 4, 6 adds up to 15. 1, 2, 6, 6 adds up to 15. 1, 3, 5, 6 adds up to 15. 1, 2, 4, 8 adds up to 15. So that's 8 15s here. We have 6, 9. One more. 6, 9, 2. 7, 8, 3. 6, 9, 4. 8, 7, 5. 7, 8, 6, and 6, 9, 7. So that's 7 more plus the 8 quad sums, which adds up to 15. So these must add up to 12, 1, 4, and 8, 3 and 9, 4 and 8, 5 and 7, 4 and 8, 5 and 7, 3 and 9, 4 and 8, 5 and 7, 4 and 8, 5 and 7, and 3 and 9, which is 12. And so this should be a 7. And that's a solution. Very interesting puzzle. Very, very interesting. All that logic too to be able to rule out certain sums. That was pretty crazy. Pretty cool, but pretty crazy. Yeah, just a lot of really cool logic involved in being able to remove possibilities of sums, right? Like the 3, 4, being able to remove the 3, 4 as possibilities with like a 6, 10 pair or a 5, 11, or 6, 9 pair, 5, 11, etc., is pretty interesting. That was very interesting how that was set up. And then also removing the ability to have 5, 10 was very cool also. Also 4, 11. I mean, just basically all the possible sums that we kept on whittling down there was a lot of cool logic there, I would say. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.